Now let's summarize whatever we have studied in previous videos. So we have studied potential difference, insulators, conductors and electrons, charges, and etc. So potential difference, let me tell you again, potential difference is nothing but the difference between two points in a circuit. Yes, the difference between 2 points in a circuit. For example, if this is 118 volts, this is 128 volts, so the potential difference between these 2 points will be 128 minus 118 is equal to 10 volts. Okay, so now let's proceed. Now we have to learn electric current. We have done electric charges, we have to do electric current. So what are electric current? So electric current is nothing but how much charge flows per second. So let's write this. Electric current is denoted by I. So I is equal to how much charge, that is Q, as we have learned in the previous video, Q flows per second, that is time. So the SI unit, everything has a SI unit, friends. So the SI unit for electric current is amperes, denoted by A, denoted by capital A, and for Q, as we know, coulomb, and for T, seconds, for time seconds. So if you are asked that what is 1 ampere, so 1 ampere is nothing but 1 coulomb per second, or just coulomb per second. Now this is 1 ampere is equal to 1 coulomb per second. Now what is 1 milliampere? 1 milliampere is equal to 1 by 1000. 1 by 1000 ampere, 1 by 1000 of your ampere. Okay, and what is 1 and what is 1? So 1 milliampere is equal to 1 by 1000 ampere, which can also be written as 10 to the power minus 3 amperes. Now what is 1? And then what is 1 microampere? So 1 microampere is equal to 10 to the power minus 6 amperes. So this is what electricity is. Electricity is nothing but just how much charge flows per second. Now what makes an electric charge or current to flow in a wire, in a conductor? So that is the potential difference between the ends of the wire. So the potential difference between the ends of the wire is responsible for the movement or which allows to flow the electric charges of current in a wire. So now let's solve a very easy sample problem. So the question is, an electric bulb draws a current of 0.25 amperes. So we are given I, that is electric current is equal to 0.25 amperes. Friends, never don't forget to mention the SI units of all the quantities, otherwise your marks will be decreased. Okay, then so I is given 0.25 amperes. So the question, first listen. An electric bulb draws a current of 0.25 amperes for 20 minutes. So the time is 20 minutes. Let's convert it into seconds. 20 into 60 is equal to 1200 seconds. Okay, then calculate. So these two are given and we have to calculate the electric charge that flows through the circuit. So we have to calculate the electric charge, that is Q. We don't know it. So according to from this or you can say from this one, from this equation, we know that I is equal to Q by T. I is 0.25 is equal to Q, we don't know. T we know 1200. Just multiply this by 100, just cut it. So 25 into 12 is equal to Q. So what is Q? So Q is nothing but just 300 coulombs. So this is what electric current is. So we know that the potential difference between the ends of the wire makes electric current pass through it. So how can we build that electric current? So you don't have to do, you have to do nothing. You just have to introduce a cell or a battery to the wire. Now what is battery, what is cell? So cell is a substance which contains chemical where chemical reactions happens and provides electric current. So when it is one in number, it is called cell, and if it is more than one in number, in quantity, for example, if I have one cell, then it is so one cell, one unit is cell, and more than one unit, for example 2 or 3 or 4, is known as battery. Now when a cell is connected to the in a wire, in a circuit, for completing the circuit, and it is connected to a bulb, which is, I think, which is glowing. Then this is the positive terminal, this is the positive side of the battery, and this is the negative terminal of the battery. Now then what will be the direction of this? So the conventional direction of electric current is from positive terminal of a cell or a battery to the negative terminal. Means the conventional current will be like this, in this way, from the positive to the negative. So friends, the conventional direction is from positive terminal to the negative terminal in this way. However, the flow of electrons is from negative to the positive, but we used to denote it from positive to the negative. This is the conventional direction. Now let's understand this more nicely. Say this is a wire connected through a battery. Here is the positive, here is the negative one. Okay, here is the positive, here is the negative one. It contains electrons. All are electrons. I'm not drawing protons to making the diagram more simple. This is just electrons. All are electrons. Here is the positive. So the conventional direction is from positive to negative in this way. But the flow of electrons is in the opposite direction, from negative to positive. Here you can see. So this is what the direction of electric current is. So friends, this is for today. Let's meet you in the next one.